Terco is a Swedish company, founded in 1963 and is today a major manufacturer and provider of equipment for engineering education worldwide. Our equipment is used at various levels for training and advanced postgraduate courses at technical schools, universities, organizations, and industrial training centers all over the world. Terco is today represented in more than 60 countries worldwide, and our products have always met recognition for high quality, durability, and meeting the technical demands of today's industry. With our products for training in power technology, we maintain a close cooperation with ABB, a world leader in electrical engineering. The Terco house in Stockholm was built by Terco in 1985 and belongs to the Terco group of companies. Welcome to Terco, a worldwide provider of technical equipment for education, and today's presentation of the PST 2000.
Hello, Stuart Sunkel, Research and Development Manager here at Terco. Today we're here at the Terco factory in Stockholm, where I'm going to give you a short presentation of our Power Systems and Transmission Simulator, or PST for short. But first, let's take a look at why you should be interested.
Every year, millions of people are left without power due to natural phenomena, component failures, or human error. We've not yet found an efficient way to store energy on a large scale. Therefore, generated power must match consumption levels at any given second. This creates a delicate balancing act which requires knowledge of intricate transmission and distribution systems. With the knowledge gained from training on the Terco PST, many of these power outages could have been prevented. As in reality, the first link in the power chain is the generator station. The Terco PST gives the possibility to study all aspects of power networks from generation to end user.
The PST 2210 generator station is packed full with components and features found in generator stations around the world.
There are many different types of generator station, such as hydro, nuclear, coal, geothermal, combined cycle, wind or diesel. The heart and soul of any generation station includes three major components: the generator, the turbine that turns it, and the step-up transformer. Let's take a look at how we implement these components in the PST 2210 generator station. The generator station panels can be divided into two functions for these components: controls and connections. First, let's look at the controls. To create power, we must first have a prime mover, or turbine. The different types of prime mover used in different power stations exhibit certain characteristics, such as reaction times and load sag, due to governing techniques and physical system properties. One example of contrasting system properties is the difference between trying to stop the inertia of thousands of tons of water flowing through a hydroelectric power station compared to stopping or redirecting the inlet of steam in other types of power stations. On the PST 2210, turbine characteristics can be set quickly and frequency controlled and monitored efficiently. With the prime mover up and running, we can then begin to generate power using the generator output controls. This generated power then undergoes transformation in a delta Y step-up transformer. This is done to counter transmission losses. Being vital, expensive and large components, the generator and transformer are both protected from fault situations by the latest IED relays, which comply to IEC 61850 standard for substation automation. All connections for the generator, transformer and relay CTs are made on the connection panels. These panels also give access to measurement points, allowing for electrical characteristic studies on not only the system as a whole, but on each individual component. Once a generator station is producing power, we may then want to connect it to an existing online network, or we may want to pair it with a second generator for increased capacity. The grid panel gives access to the external power network, and together with a comprehensive array of synchronization tools, critical parameters can be monitored and adjusted in order to synchronize between the grid and one or more generators. Dual outgoing lines allow for different system configurations. Both are monitored for fault conditions by dedicated IED line protection relays. The fault simulator panel is used to connect and control numerous true-to-life faults, scaled down for safety, of course. Connecting real faults lets us study and understand the numerous protective functions of each relay. Simultaneously, it allows us to identify and practice the correct course of action to clear and rectify problems when faced with a fault situation. With our generator station online, we then need to send the power to where it will be used. To do this, we use the PST 2220 Transmission and Distribution Lines module.
Power is commonly generated far from where it is finally consumed. Therefore, the generated power must be sent long distances to where it is finally consumed.
This is done via a national power grid. The grid is a network of transmission lines, distribution lines, and underground cables, which act like highways for the generated power, allowing it to reach the many places where it is needed. The 2220 transmission line module provides real-line models for high voltage overhead lines, medium voltage overhead lines, and underground cables. The characteristics of each line, due to parameters such as length and voltage level, can be studied in detail, including important concepts such as line capacity and power quality, which help to prevent blackouts and keep the power flowing. As power nears the end consumer, the high voltage must be scaled down to more practical levels. This is one of the main jobs of a substation.
The PST 2230 Regional Substation module is the hub of the simulated power network.
Here the incoming voltage is received from distant generation stations onto the dual HV bus via the switchgear. This voltage is then transformed down in magnitude and distributed out to distribution lines from the two outgoing feeders. As in reality, the substation is guarded from internal and external faults by the latest IED relays, which provide protection for the step-down transformer, the incoming high voltage lines, and the outgoing medium voltage feeders. The 2230 also houses a fault simulator for easy connection and control of fault situations. The Users and Experiments manual provides step-by-step instructions on how to connect different types of faults based on actual situations out in the field. The Transformer Connection panel provides a means for more intrinsic studies on the Y-delta-Y transformer. Substation output is also controlled here by way of a tap-changing actuator. After leaving the substation, our power is then distributed around the region, ready to be put to good use in different types of load.
Eventually, our generated power completes its journey to the end user or consumer. Power consumption in the PST is carried out in the PST 2240 load module.
Consumers take many forms. Industrial customers, such as factories or process plants, have different power demands to those of domestic customers, such as your family home. The 2240 variable load module includes easily selectable industrial three-phase loads, together with domestic single-phase loads. This lets us simulate both normal and abnormal load conditions and challenges faced by power companies today, such as over and underload, unbalance, and more. This completes the standard PST setup, including generation, transmission, distribution, and loads.
Now let's take a look at some additional modules which enhance the capability of the standard PST.
The correct running of a complete power network is an extremely complicated balancing act. A lot of information from different parts of the network must be gathered and displayed in a control center, giving operators the possibility to monitor and control the entire network from a single location. This is done via a SCADA system. The Terco SCADA system, using an industrial standard solution, allows multiple users to monitor and control the complete power systems and transmission simulator. Full access management allows for user privileges to be set, giving rights from viewing only all the way up to administrator level. Additional modules are available to enhance your power system simulator, such as the additional generator module. This allows for additional experiments, such as load sharing and generator characteristic comparison between cylindrical and salient pole machines. The Power Factor Controller module provides an opportunity to learn more about methods to increase system capacity by compensating for reactive power. The 2270 mobile generator module adds an extra generator to the system, extending both the system capabilities and increasing the number of people running simultaneous experiments. Technology doesn't stand still, and neither do we. Power networks are currently undergoing radical changes, and we at Terco are constantly looking for ways to upgrade the PST and implement new technologies as they become available. No Power Laboratory is complete without the Terco Power Systems and Transmission Simulator. Installation and training is carried out on site by Terco engineers and technicians and can take between 3 days and 2 weeks to complete, depending on the number of modules and the on-site conditions. Successful training is rewarded by an official Terco diploma.
That's all from me here today, but before I go, I'd like to leave you with some advice. Invest in a Terco PST for the future and learn to make power problems a thing of the past.